All right, in this lesson, we're going to learn about what is the unit circle. So you're going to hear the word unit circle all the time in Algebra 2, pre-calc, calculus. A unit circle is nothing more than really just a circle with a radius of 1 unit, okay? So here's a circle here. So what we're going to do is we're going to think of it like, like this circle here has a radius of 1 unit, okay? So obviously right away we could, get some coordinates here. If this radius is 1, this point's 1, 0, this point is 0, 1, this point is -1, 0, this point is 0, -1, right? Now, as your radius kind of moves along here, the highest value for the y coordinate is 1. Anything right here, the y is a little bit less than 1. Your x coordinate is right here. It's really the coordinate of the point, but it also translates to a triangle. So, you think of this, this angle right here as think of it like a triangle looks like that. Okay, and this leg, the vertical leg of the triangle, is the y coordinate, which is the sine of your angle theta, and the horizontal leg is the x coordinate of the um, x coordinate of the point right there. So it's the cosine of your angle theta. Okay, so you look here, no matter where your angle is, so this one's right here, it's this point right here. This is the point on the unit circle, but this is the angle here. The angle is made right here with the positive x-axis and wherever it stops, and we call that theta. And you end up having a right triangle is what happens. So if I look here at this right triangle, right here, this triangle, the horizontal leg is cosine theta, and the vertical leg sine theta. So it goes all the way around the circle. We'll get into more depth on the other quadrants as we go. Now, some other trig functions here. Tangent of theta. If you ever want to find the tangent, as long as you know these two coordinates here, the cosine of theta and the sine of theta, if you divide the sine of theta by the cosine theta, that gives you the tangent theta. And then the cotangent of theta is just the reciprocal. So you flip it, you do the cosine of theta divided by the sine of theta. And then secant theta, you're going to see that trig function. That's just the reciprocal of cosine. So if you ever know the cosine here, just, flip it. It's divided by 1, do the reciprocal. So it'd be 1 divided by the cosine theta. And same thing with cosecant of theta. It's 1 divided by sine of theta. Okay, now a little trick and I guess with these two here, I guess I didn't write this here, but that implies that, cotangent of theta is equal to 1 over the tangent of theta. Okay, they're reciprocals of each other. Right there, you can see that they're flipped. So, but the trick that I use to kind of remember these is I like to say, okay, well, each pair of these, has a co. So I got cotangent paired with tangent. So if I look at, cotangent theta, tangent theta, one of them has a co. I have secant and cosine. So if I look at these two here, secant theta, cosine, that makes me remember which one's the reciprocal of which. And then if I look at cosecant and sine, okay, that pair, one of them starts with co. Okay, so that's how I remember it. All right, a couple other things that we're going to need to know. Rotating angles. A positive angle goes counterclockwise. A negative angle goes clockwise. Okay, so you're going to need to remember that. So this angle here, this would be like, I don't know, like a negative 45 degrees, and this would be like a positive 45, roughly. Okay, so another thing that we're going to learn is called standard position. An angle is in standard position if its vertex is located at the origin and one ray is on the positive x-axis. Okay, so the ray on the x-axis is called the initial side. So I got a little picture right here, initial side. This side never moves. And then the moving side is called the terminal side. So it ends up looking like this here. If this is I start right here, and then this is my angle. So this would be a positive angle. This would be between 0 and 90, because obviously up here, this is 90. And then this is another 90, so that's 180. And this is 270. And then we started at 0 and we end at the same spot, which is really the same as 360. So anyways, it just depends on the direction. So if I go this way, this would be like, I don't know, like a 170-degree angle. Okay. Now, if I went the other direction, went that way, that'd be like a 190-degree angle. Okay. So that would look more like this. If I start here, I go 180 and then 10 more right there would give me that 190. So either direction, they would be the same angle there. And we're going to talk about that here a little bit on the next slide. All right, so coterminal angles. So basically, coterminal angles are angles that are in the same position. They share the same terminal side. So if you look at this picture here, I have 45 degrees. So 45 starts right here, goes right there. And then I have negative 315. This time I go that direction, but I end in the same place. And then I got 405. So I start right here. There's 360 plus another 45, same position. So it's as simple as adding or subtracting 360. So, I started with 45. We usually like the angle to be between 0 and 360. So when theta is between 0 and 360, that's the angle we usually like the most, okay, because it's just easier for us. But, if I keep adding, if I want to go this way, I'm going to add 360. And then I'm going to add 360. And you can keep on going, okay? And if I want to go the other direction, I can subtract 360. And you can kind of just keep on going. It almost is kind of like an arithmetic sequence. But, when I go here, I get the 405. If I add another 360, that would be, let's see here, 405 plus 360, 765. Okay, and you can keep on going. And then same thing in the other direction. That one we said was negative 315. And then I do it again. Negative 675. And keep on going in the same direction, okay? Negative or positive forever. So there's infinite number of coterminal angles, okay? All right, so what's a reference angle? Reference angle is the smallest possible angle made by the terminal side of the given angle with the x-axis. Okay, so with the x-axis, okay, right there. So if you look here at your 3 or your 4 reference angles that we have drawn here, this angle right here, this angle right here, this angle right here, and this angle right here. So it's always made with the x-axis. Okay, so don't accidentally make it with the y-axis. That's a common mistake, but always right here with the x-axis, okay? So it's really just kind of like geometry if you think about it. Like quadrant 1's real simple. Whatever your angle is, that's your reference angle. So quadrant 1, super easy. Reference angle equals given angle. Quadrant 2, think of it like a geometry problem. Like if I have here, we know that a full, line here, this is 180, right? So, if I wanted to find x, and, I'm going to erase this here. Whoops. And if I wanted, let's say I knew that this angle right here was, I don't know, like 140. Well, what would this be? Well, these have to add up. These are supplementary. They add up to 180. So, x plus 140 equals 180. So you would minus 140, and that'll give you your x. Okay. So that's how you do it there. It's 180 minus the given angle. Over here in quadrant 3, it's a little bit different because you're going past 180. So let's say that it looked like this. Let's say your angle was, again, just think of geometry. Let's say you wanted to find this angle, but you knew that this angle all the way to here was, I don't know, let's say, 220. Well, again, we know that the straight line right here is 180. So how much past 180? Well, it's going to be your given angle minus 180. That gives me my reference angle, 40 degrees. Okay, so x equals 40 degrees in that case. Okay, and then over here in quadrant 4, it's how much shorter you are from a full circle. So a full circle is 360. So you just subtract 360 minus your given angle. Okay, but it's basically just geometry, adding angles. All right, so the last thing here are signs of the trig functions. So let's just focus about, I'm going to cross these off for a second here. Let's just focus on sine of theta, cosine theta, tangent theta. Okay, so I want you to think back to the unit circle here, like we were learning here. We learned here, here's my unit circle. Okay, and if this is the origin here at 0, 0, and it goes cosine theta, comma sine theta, oops. All right, think about it. X, if I move right, we know the cosine's positive because I'm moving to the right. We know where the origin is. If I move left, cosine's negative. So you can kind of see here, cosine theta is whoops, I did my sign wrong, is positive in these two quadrants. And it's negative in these two quadrants because I moved left over here. And then over here, sine is positive in these two because I move up. And then down here, it's negative because you move down. And if tangent just divides the two, so a positive divided by a positive would give us positive. This is a negative cosine and a positive sine. So a positive divided by a negative, positive divided by negative equals negative. So your tangent of theta is negative. Over here, cosine's negative, sine's negative, so negative divided by negative equals a positive. So that would make your tangent positive. And then down here, you have negative divided by positive, so that's going to equal a negative. So your tangent. Okay, so what that does is to simplify all this, we just came up with this acronym here. I like to call it all students take calculus. Okay, so all are positive, sine is positive, tangent's positive, cosine's positive. Okay, and that just deals with sine, cosine, tangent. But if you remember what we were talking about here on the first slide, cosecant theta is just the reciprocal of sine of theta. So if sine of theta is positive, if I just flip it, I'm not adding any signs or anything, that implies that cosecant will also be positive where the sine is positive, okay? And then if you remember here that, cotangent of theta is just the reciprocal of tangent theta, because I'm only flipping it and just doing the reciprocal, I'm not actually adding any negative signs. That implies wherever tangent's positive, so is the cotangent. And likewise, same thing with cosine, because the secant is the reciprocal of the cosine, okay? So there you go. You just flip them, and now you can use this to kind of help you a little bit. So, all right, so let's do some questions here. So rotate 137 degrees within 10 degrees. So here's 90, here's 180, so it's somewhere in between here. So this is 45, halfway down the middle. So 90 plus 45 is 135. So I'm just going to go a little bit past there. And there's my point, okay? So that angle roughly right about there would be 137, okay? Negative 29. So I have to go negative. Now this is 45's in the middle. Now if I cut it into 3 equal slices here, that would be 30 each because 90 divided by 3 is 30. So I'm going to do my best to kind of do 1/3 right there, just a little bit less. So I'm going to get this angle right here, and I'm going that way. I like to put an arrow on it, okay? Next one is 383. So I have to go a full 360 and then 23 more. So it's going to look something like this. There's my 90, 180, 270, 360, and then I go 23 past there. Something like that, okay? All right, so now that we know how to graph angles or draw angles in standard position, we're going to now find coterminal angles. So just add or subtract 360 till you get it between 0 and 360. So I think I have to subtract 360 3 times. I think it gets it down to 180. Okay. So actually we know enough to know, like, our unit circle here, at 180, we've already talked about it. That's this point right here. So we actually know the cosine of 180 is -1. Sine of 180 is 0. So if you want to take your calculator, just make sure it's in degree mode. But you could type in cosine 180, you should get -1, and cosine or sine of 180, you should get 0. All right, so this time I'm going to add 360. I think I got to do it 3 times as well. And let's see what we get. I start with -891 plus 360. 3 times, that gets it there, 189. Okay, so that would be in quadrant 3 if I were to graph it. And my reference angle equals 9. I'm sorry, not 19. It equals 9 because you're 9 degrees past 180. Okay, just because we're going to do this and coming up, I figured I'd mention it. All right, so rotate, find the reference angle for 148. So 135 is right here because this is 90. 45 is 135. 148 would be like right around there. So 148. There it is. So it's 180 minus 148, and that gives me 32 degrees. That's my reference angle right here. Okay. Now, if I want to find reference angles in other quadrants, you would just simply, we would draw the 32-degree angle here. We would do the same thing over here. Okay. And we could do the same thing in this quadrant. Okay. And then it's going to eventually on the next couple slides here, I'm going to have problems where you have to find all 3 of these angles in standard form. So like this one right here in red would be like all the way to there. What's that angle? Okay, the purple one would be, all the way around there. Okay, and the orange one is just exactly what it is because it's in quadrant 1. It's 32. All right, here's another one. 198. So 198, there's 90, there's 180. 198 is about 18 degrees past there. So there's your angle here, 198. So that's an 18-degree reference angle. So it's 198 minus 180. Okay. So now we're going to do it without graphing it. So 325, again, remember your quadrants here. So you got, 90, 180, 270, 360, or 0. 325 is in this quadrant somewhere, so it's going to be 360 minus 325. That will give you how much you have left, which ends up being 35 degrees. All right, so this time we're going to have to find a reference angle in each quadrant and then rewrite what each angle would be in standard form. So I always like to just sketch a little picture here. So 151 is going to look like something like that, probably. So to find that reference angle, I'm going to do 180 minus 151 because I'm in quadrant 2. So that gets me 29 degrees. Sorry, I can't ran out of room there. All right, so 29 is my reference angle here. So it's basically like I'm going to draw reference angles in each quadrant. Same angle here, 29. Actually, let me use a different color for that last one. And this one's a little off here. That looks a little better. So it's like you got a 29-degree angle in each one. All right. So this pink one here is 29 degrees if I were to measure from there to there. Quadrant 2, we already said that was 151. Quadrant 3, I got to go all the way here and then 29 past 180. So 180 plus 29 is 209. And quadrant 4 is the green one. It's all the, whoops, I wanted to do it in green, sorry. It's all the way over here. So that's obviously 360 minus 29, 331. Okay. First, find a coterminal angle. So I got to add 360 a couple times. I'm just going to take my calculator. I'm going to type in negative 785 plus 360 plus 360 plus 360. I got to do it 3 times to get it between 0 and 360. So 295, that's in quadrant 3 because it's between 270 and 360. And then the reference angle. So I'm sorry, that's not in quadrant 3. It's in quadrant 4 because it's between 270 and 360. So then 360 minus 295, that'll give me my reference angle, which is 65. Okay. All right, so I'm going to go back to my, well, if it's just sine or cosine, it's kind of easy, actually, if you think about it here. So cosine positive, so I'd have to move right. Okay, so remember, this is 0, 0. So if I'm moving right, cosine's positive, I can get rid of those. So it's down to these two. Sine is negative. Sine's negative in these two. So that eliminates this one. That's the quadrant 4. Okay. Or you could go back to the all students take calculus. So cosine positive in these two, and then sine negative in these two. That's the one that they overlap. Okay. So maybe this time I'll do the all students take calculus way. So you got all students take calculus. So I'm going to just kind of highlight and then we'll just take the overlap part. So cosine negative. So cosine's positive here, all and cosine are positive. So this is my cosine negative. And then tangent positive. Tangent's positive in these two. So here and here. So this is my overlapped region right here. So that's quadrant 3. Okay. So I'll do the same technique here. I'm just going to kind of draw my quadrants here. I'm going to go all students take calculus. So cotangent, this is going to be the same as tangent. Okay, so you could just think of it like tangent theta less than 0. These are going to be equal. So I'm going to look here. Tangent is positive in these two. So these are the ones where tangent's negative or cotangent. Cosine negative is these two where it's positive. So cosine's negative in these two. Therefore, this is my overlap section, quadrant 2. All right. All right. So that's it for this lesson. Hope you enjoyed it. And we'll see you next time.